Hello and welcome to Automation Best Practices Workshop. In this workshop, we are going to learn what is an automated atomic test and how to code automated atomic tests. We're going to learn multiple types of login testing, such as HTML web forms and JWT. We're going to learn about component testing. We're going to learn how easy it is to add a test ID to our web application. We're going to learn how to test links and tabs. We're going to learn how to replace our end-to-end tests with component tests, as well as learning visual end-to-end testing, cross-browser and cross-platform. And then we're going to combine all of that together into a single CICD pipeline where we can run all of our automated tests. The technologies that we're going to use are React.js, Cypress, WebDriverIO, React Testing Library, Jest, Screener Visual End-to-End Testing, Sauce Labs, and GitHub Actions. My name is Nikolai Advolatkin. I'm a Senior Solutions Architect at Sauce Labs and creator of UltimateQA.com. I am super excited to be teaching you this workshop, so let's go ahead and dive right in. The workshop is broken up into 5 sections. If you want to see everything about the workshop, you simply navigate to this URL up here, and you'll see a table of contents. Every section is a discrete block that we are going to work on. So if you want to check out one section at a time, you can click on a link of each section, and in there, we are going to have a bunch of activities and knowledge that we will learn in that section. We're going to go through one section at a time and cover the topics in each one of these sections. Now, you need to do your own setup, and the setup instructions are here. You're going to be installing Node 14 LTS. You're going to create a fork of this repository. You're going to create a fork of another repository, which is also here. And once you clone the repository, you'll ultimately pull up your IDE of preference. We're going to be using Visual Studio Code. And then once you are inside of the appropriate directory, you will do a cd to my React app, and then you'll do an npm install. And once that's installed, you'll do an npm start, and that will pull up our application that we're going to be using throughout our course. So here you can see our application is about to come up. So this is one of our sample apps. And once you have it running, you basically know that you are good to go with this repository. And then there is one more repo that you'll need to clone. That's over here at these examples. And we are only going to use these examples for testing logins. Okay, so go ahead and follow through these directions yourself on setting everything up. Make sure that you have everything available. This part is the environment variables. You don't actually need to do them right now. You may need to do them in the future, but for this workshop, you don't need them right now. So with all of that said, let's go ahead and jump into automated atomic tests and talk about those. So in this section of automated atomic tests, you will learn what is an automated atomic test and how to actually code one. The software under test that we're going to be testing is this application here, saucedemo.com/v1. The v1 is important because it is an older version of our application that has some functional code that I need to use in this demo. Without v1, it's a newer version of the application that doesn't have that code, and so it's important that we visit the v1 version of this application for the testing purposes. So here it's a sample e-commerce app. You can see that we can log in as a standard user and secret sauce. One thing that I need to point your attention to right away as we're exploring this is what happens in the application tab of our web app. And so we can see here that we have local storage and we have session storage. Once we log in, you can see that our session storage has received a session username, standard user, which was the user that we just added. You can see there are a bunch of items. When you add these items to a cart, you can see exactly what happens to our session storage, how we have cart contents added, and then the array of the element which we added to the cart. You can go to the cart, you can do the checkout process, and ultimately once you finish the checkout, that's pretty much it. So, automated atomic tests. An automated atomic test is a test that validates a single feature or a component. One thing that you will notice as we write automated atomic tests is that they have very few UI interactions and typically touch a maximum of 2 screens. Of course, nothing is black and white in software development, but I say typical end-to-end tests break the AAT pattern. The way we think of end-to-end tests, multi-screen flows, those actually don't follow the automated atomic tests pattern. And we will learn in this entire workshop how to break those up into tiny little atomic tests. Furthermore, automated atomic tests actually meet several requirements of good tests as specified by Kent Beck. This is really interesting because automated atomic tests are very powerful, but they also meet these criteria. And as a result, they are powerful because they meet this criteria. They are isolated, they are composable, and they are fast. And of course, if you want to read more about what makes a good test as specified by Kent Beck, you can click on that link there. Just one thing that I do want to mention is that typically automated atomic tests are already being written at the unit and integration layer of the system, but our UI automation continues to lag behind. And so my goal here is to show how we can achieve this with UI automation to achieve all of the benefits that automated atomic tests bring. So at this point, I have a question for you. This test over here, is it actually atomic? Go ahead and take a look. Think about what this test does in terms of our demo application, and then think about whether it's atomic or not. So you might be surprised, but this test is actually not atomic. The reason why it is not atomic, even though it's already extremely simple and extremely small, is that it validates at least 2 features. First, it signs into our application, and then it validates that that products page is visible. So that's already one feature that's tested, is the sign-in feature. The second part that this test validates is that we can actually add an item to a cart, right? So we're adding an item to a cart, and then we're asserting that it should have one item in the cart. And so the reason why this test is not atomic is ultimately what it's trying to test is that we can add an item to a cart. However, because we don't know at this point how to make this test atomic, we have to go through a login process, which is super common in web applications these days. Most of them have a login process that we have to deal with. But not only that, we might have to go through several more steps to set up a state of our web application before we can actually test the feature that we want. So then the question becomes, how do we break up these tests to be more atomic, to focus on the features that we actually want to test and avoid touching the UI for everything else? So another question for you to think about and answer is, how many atomic tests is this really? Give it a thought, write down your answer. When you come back, I'll tell you. So this can be at least 2 tests, as I already talked about. Number 1, it's a sign-in test, where these 2 lines, we validate that a user can successfully sign in. Number 2, it's a test to validate that we can add an item to a cart. It could potentially be a 3rd test, where we validate that the login page simply renders, right? If you want to start with a very simple test, you can simply open up loginpage.visit, which is done right there, and assert that the application has rendered successfully. You can do that test as well even though this one over here will actually fail if that page doesn't render successfully. If you're enjoying this tutorial and want to support this channel, be sure to hit the thumbs up button for the video. And if you want to be notified of every time a new tutorial is released, hit the subscribe button. So let's go ahead and actually get started with Cypress. So this little man over here means that we're doing an exercise. So this is where you should be hands-on keyboard, coding along with me and doing these practice exercises. So what you're actually going to do is in the directory of automated atomic tests. So you're going to kill the app if you already have it running using Control-C. We are going to navigate to one level up, and then we're going to navigate to automated atomic tests. Okay, you're going to do an npm install. Once all of that installs, you're going to do npx cypress open, and then we are going to take a look at exercise.spec.js. The way I've outlined this workshop is our exercises that we're going to be doing are in exercise.spec.js, and our solutions are in a file called solution. I just ask that you please don't peek at the solution as you do the workshop. Obviously, you'll get a lot more out of the workshop. You'll get a lot more out of the workshop if you're actually doing the exercises. But then, of course, at some point, you can take a look at the solution when you are ready for the answer. So let's go ahead and follow these commands and do them together. So we're going to do npx cypress open. So one thing that comes up is this UI here. This is the Cypress test interface that shows the tests that we have available in our current working directory. And so if we open up automated atomic tests, we go to Cypress, we go to integration. By default, when you place any test file in here, it will show up in this UI that you see here. And so you see a corresponding file for exercise and a corresponding file for the solution. You can click on a file and it will actually execute. So we are opening up this UI. And so here we can see that this test has executed, and we have a test that's called exercise for automated atomic tests. We have a home page that should be visible, and for now it's failing because of this cross-origin frame. And then we have another test products, and it adds that, checks that should be added to a cart. It's passing, but there were no commands issued with this test, and that's because they are both exercises and they are not fully finished yet. And so if we actually take a look at the code here, we can see that here are the exercises that we are trying to achieve. We can see the code that's outlined in here. Here's a describe block that says what a suite of tests is. And so here we have our exercises for automated atomic tests. This is another context. There's another little mini organizational feature that's saying we're testing the home page. We have a before each block that executes before every single test method. And here we are opening up our base URL that's going to come from cypress.json. So if we come here in here and in cypress.json, you can see we have set our base URL. And then here we are clearing session storage just because it's very important to maintain a clean state between every single test. Okay, and here we have two tests that I've provided instructions for you on how to solve. So once you are actually at that state, your challenge is to break down the tests that we have into atomic ones. In fact, you can see all of the instructions here, and you can see how to accomplish this. These light bulbs mean that I've provided you a hint on how to perform different kinds of operations. Okay, and so your challenge will be to create automated atomic tests. But one thing that I do want to quickly cover before we do that is how we can actually create automated atomic tests with this application. So with our application, the way that it works, as I already kind of showed you, is whenever a user logs in, we are able to set our session storage with username and pass in the value and card contents and also set the value of that. So if we are trying to test a login, for example, we can do that through the standard UI, right? You can test the login, assert that the next state, which would be the next page, is visible. Good. Login works. But now, do we actually need to log in order to add an item to a cart? No, we do not. And how we can do that, for example, is if we navigate to this page /inventory.html, you can see that it automatically takes me to this page. And in fact, let me do this here as well. Oh, good. This doesn't have anything set in it. So you can see that we've hit this URL. There is no user or no items set right now. So in order to be able to test that we can add an item to a cart, we can do something like this. And let me show you. I even gave you a hint in how we're doing that using Cypress test code. So we're using site.set test context that we created in support/commands.js. So if we come back here to support commands.js, you see here that I've written a function for you called set test context. This takes a data object and you can pass in path, products, and a user. So this method, what it does is it navigates to the URL and then it clears the storage, and then it sets session storage by setting session username and setting cart contents. And what does that actually mean? Let me show you in the UI of our application. So if we come back here and go to the console, we can do session storage.set. We can do session storage.set item. And then it takes two arguments, which you saw in my code. It takes a session username, which is standard user. This will allow us to bypass the login. Okay, let's take a look at our application. Boom, session username, standard user has been added. And now let's add an item to a cart, and that was using cart contents. And here you can specify the item number. So you can say 1, for example. And so once you've done that, once you refresh, okay, there we go. I was entering this item incorrectly. It should be like this instead of just an integer. And so once we set that, we see that now we have cart contents added automatically to our cart, and we also have a user that has been logged in. So you can see how we've just bypassed the login by visiting this URL and setting the session username. And now we can test whether a user can add item to a cart. If we wanted to take this a step further and we wanted to do a checkout process, we wouldn't need to touch any of the pages before. We could come to this page, for example. We could add an item to a cart using the method that I just shared with you right here. And then we can use the UI to go through the rest of the checkout process. Okay, so now with all of that said, you should be ready to do the exercise. Your code will simply go here and here. and here. And all the steps have been outlined for you, and all the imports have already been made for you as well. So give that a shot. When you come back, I'll tell you the answer. All right, so let's solve this problem together. Let me show you the workflow. So we can do npm Cypress open, which opens up our UI. Now, I'm running here in Edge browser because I noticed that our web app was actually having some issues with Chrome 90. So if you're having issues running these tests, I recommend you select Edge. So that's what I selected. And then we're going to open exercise spec.js. We'll move this to the side. And so now you can see our tests have executed. They all pass, but they don't have really any code inside of them. So let's put this on one side and then our IDE on the other side. This is a nice workflow that I like to have with my web apps. And then we can come to exercise.spec.js, close all these windows, and we can work on these tests together. So the very first one is using our login page to check that it is visible, right? So we've already visited our URL. So our application is open at this point. So our test, it should be visible, simply should validate that our application is visible, right? And so as we can see here, we can use the login page, which we've already imported. And then the instructions say that we have a screen object, and we can say should, open and close parentheses. And then here you can see all this IntelliSense being helped from Cypress. That actually comes from here. When you add this to the type of your file, you get that nice IntelliSense, so you don't have to look at the API docs. And now this will open up all the possible conditions that you can have for the screen, and you can say b.visible. So you can kind of just use almost kind of native language in order to create these assertions, right? And so take a watch of this window on the right. As soon as I hit save using Command S, the test will rerun. So you can see that our it should be visible test ran here. And if we expand it, you can see before each, we executed the visit and clearing the session storage. Okay, great. Next, we are getting this hashtag login container button, and we wanted to check that it was visible, which in this case it was. Now, if you wanted to be coding these tests on your own, right, without obviously having all the code already implemented for you, you can open Selector Playground here and select the appropriate element. You can see that Cypress actually provides you a locator, right? So if you did want to find a locator, you can just simply drop that in here and then perform the appropriate operations with that locator. And if you wanted to do your own inspection, you definitely can, because we are in a browser, so you can just click inspect, bring that to the bottom. And now you can inspect your own elements here in the application. So you can see we can start doing different kind of operations here. Okay. The other trick that we can do is, while working on our test, we can only focus on our tests. So for example, here you can see we have 3 tests that we have running, right? If we only want to focus on a single test, we can come here and say it.only, okay? And then once I save, you'll see that only a single test appears here in the UI. So we're just focusing on the test while we're coding it. You can afterwards remove it so that all of the tests execute. It only executes one test at a time now. And so now we are going to try a UI login with a standard user, right? That's just validating that our application can successfully log in with the appropriate credentials. So we can come here right below the step and do our login page, and then we can do the sign in method. And then we can use our login users, which has already been imported. And then there's a standard user on that object. Okay. And then afterwards, we can use our products page because it will navigate to the products page to make sure that the screen is visible. Screen should, and then we'll do the same thing as before, be visible. Okay? Give it a save and let's see what happens. All right. So you can see that this test executed. We can have a lot more steps here now. You can see that we, of course, opened up our URL, and now here we are getting our element. And here we're typing in a string. You can see exactly what happens before and after. See, if I hover over this, it shows the before and after what happens with this action. Here's the password field. Here's the typing before and after. And then here's the clicking of the button before and after. And then here is, you can see we're already at a new page, right? So page loaded. Here's that new URL. And here we are getting an inventory list and asserting that it's visible. So if we wanted to simply look at our solution, which we don't need to actually code out the tests, you can see that this is what the final test looks like. Visiting the appropriate URL, clearing the session. You can see now that this is the test that ultimately allowed us to be atomic, which was that the products should be added to cart without a UI login. So what did we do? Exactly the same steps that I showed you, we did manually. Visiting inventory page directly, not visiting any other page. Oh, and at this point we visited the first page. We injected all of the stuff in here, and then we visited the inventory page and got the inventory item, and then made sure that we had a total of 1 items added to our cart. Let's compare that with the actual code. So here's that actual code in solution spec. So here's exactly what happened. We set the test context, passing in a user and the inventory page. This is, of course, code that we wrote that you can write in your applications as well. And then this is basically performing the operations without actually touching any HTML elements. And then here we add an item to a cart. Now we're actually interacting with the UI, and then asserting that our app header has a single item. And so that's exactly what you saw in that test. So with all of that said, that basically wraps up this automated atomic tests portion of making a single test atomic. We've learned that we can use automated atomic tests to validate a single feature at a time. We learned that we can test the UI through the login only once, and then the rest of the actions we can use other mechanisms to bypass the UI before actually testing what we want to test. And in this case, we bypass the UI directly by modifying session storage in the browser. However, one caveat here is that most applications don't actually behave like this. They don't have authentication happening through the actual browser as our demo app does. And so in the next sessions, we're going to learn more realistic ways of testing logins with JWT, with HTML web forms, and that it will be more realistic. And we will tackle that in this section here. So let's talk about how to test logins efficiently. And in this section specifically, we're going to learn how to test a login without using the browser with an HTML form, and another one using JSON web tokens, which is probably one of the most common authentication mechanisms on the web. Logins are a necessary evil for the majority of web applications that exist out there. We all have a login, but they make testing extremely hard because we always have to go through the login in order to proceed with the rest of the scenarios. And so in here, we're going to continue along our path of learning how to separate login functionality from the rest of the test and making our test atomic. So for this specific portion, we're going to use this repo here because Cypress example recipes had several really nice web applications that are ready with different kinds of login examples. So all you have to do is make sure that you fork this repo, clone it down to your machine, and then you're going to follow these instructions and do an npm install and get set up. So once you have all that done, you will be good to go. We can pull it up together. So I'm going to come here. I'm going to pull up Cypress example recipes. We can close this one out for now. This repo, we're only going to work for login testing. And then after that, we'll go back to the original repository. You're going to make sure you're here in this repository, and then you're going to run an npm install. And then we're going to navigate to examples, test login, and then HTML web forms. And then we're going to do npm run dev. By the way, make sure that all your previous processes have been stopped from the previous session, like you were running Cypress, so you can use Control-C to stop that server. So npm run dev is going to do two things. It's going to open up our application under test, and it's also going to open up Cypress. Now let's go ahead and log into this. So this is what happens when you are able to successfully authenticate into the application. If we take a look at our application like before, by coming in here and looking at the application tab, what we're going to see now is we actually have cookies from our application. You can see the URL here, and here is a cookie that was dropped. It's called the Cypress session cookie. And this is how we are able to authenticate with a web form. So let me also show you what happens when we actually authenticate it. So we can clear these cookies, and so then we'll no longer be authenticated. If I try to do this, you'll be unauthorized. So if we go back to login and we take a look at our network tab, let's clear our network tab as well. And now do Jane Lane and password 123. So the way a lot of authentication mechanisms work is that they send a web request to some endpoint in order to authenticate a user. So in our case, you can see we are sending a web request to localhost 7070 and /login. Actually, I apologize. We don't want to cover that portion right now. Let's proceed here. So let's open inefficient.spec.js. So in our Cypress UI, we'll click inefficient.spec.js, and we will watch it run. Check out all the tests that it performed, right? This is logging in through HTML forms inefficiently through the UI. You can see that this test should log in with valid credentials, right? So it visits the URL, enters username and password, and then asserts three things. First, that the URL includes /dashboard. Second, that there's a header with Jane Lane. And third, that there is a Cypress session cookie, right? Because if we're logged in successfully, there should be a cookie dropped from our application. Now, next, it does that we can access /users, right? So log in, do the stuff, and then hit users, and then expect the URL to contain users, dashboard, admin, same thing. And we can even do a negative test, which I showed you, but just to make sure, you try to hit dashboard, right? And make sure that we have this message that says you're not logged in and cannot access this page. So that means that you're not authenticated in this negative test, while in all of these, we were obviously logging in through the UI. So what's the problem with these tests? Take a moment to think about it. Pause the video. When you come back, we'll talk about it. Well, the problem with these tests are that UI tests in general are not efficient in terms of doing testing. They touch so many layers, meaning they touch the UI, they touch the middleware, they touch the systems in the back end, and they have to talk through all of that, and everything has to work together for that to be successful. And that's why so many models for testing exist to discourage the amount of UI testing that we do. And here's a little diagram that kind of shows you how the best UI test that we will ever write will never be more efficient than the best unit test. And that's just simply that automation pyramid paradigm, the testing diamond paradigm, testing trophy. They're all there basically just talking about how unit tests are faster, you can get a lot more feedback, they are drastically easier to write, and their reliability is high, creation cost low, maintenance cost low. As compared to UI tests, they are simply that much less efficient. I mean, even thinking about in terms of execution time per test, you're seeing these Cypress tests running pretty quickly, right? So all of these tests ran in 2.61 seconds on my local machine. Obviously, this is not running in any cloud provider. As soon as we start introducing an actual server and not testing on our local machine, this will become a lot slower. And seconds are already thousands of times slower than milliseconds just by default. And so you can see that even the best UI tests are already hundreds, if not thousands of times slower than unit tests, not to mention the maintenance costs, which are always the biggest disadvantage and the biggest pain in any software engineering project. So let's actually go ahead and improve our tests. With everything that we've been learning, we need to understand how we can log into our application without actually touching the UI. And so let's do this exercise here, where we're going to open up this file inside of our code editor and inside of Cypress, and then we'll take a look at what's going on. So here, if you come to the standard place, Cypress integration exercise spec, I'll close this one over here, you can see that we have already implemented a few tests for you here. We've set everything up in order for this to work. Now, one thing that's very interesting to see here is this fetch user function. This is what actually allows us to authenticate and log in as a user. So what you can see, this authentication is actually a simple post to this server that's running user/authenticate. So in fact, if we open up our terminal back again, when we start up our app, which was way up here, no, it doesn't actually show us that the server is running, but if we visit localhost 4000, so in this exercise file, we will see everything already written for us, where it says logging in using HTML web form, right? Here we have a context block that groups all of our tests that we're going to be running together. Before every single test, we're going to clear cookies because we want to make sure that our environment is clean. And here, as you can see, our end-to-end test that validates the correct app behavior. So let's actually pull this up side by side with Cypress. So if we come back here and pull up our exercise spec, so all of our tests have ran, and here they are being displayed. And let's put it here on the right. So that's this test here where it logs in through the UI, right? This is the standard thing that we're typically used to doing and what you have seen before. So now that we have this validated, we don't need to actually check that this functionality works. We know that it works. So why would we repeat it through the rest of our tests? And so now here is where your exercise is going to come in, where you're going to need to log in to access the dashboard, and you can bypass the UI and yet still log in. And then here are the exercises to do, logging in without the UI, right? So here is needs login to access this dashboard, right? It logs in. It does not log in. And then you can see that it hits here and then it gets that error. And then here's the other test that you've seen as well. Now, here are the exercises. Let's take a look. And actually the bypass one is important for you to see. So the bypass one is where we're actually going to make a web request to do an authentication with our application. So the web request is a simple post on this endpoint 777077/login. We are going to say that it's a form, and we're going to supply the username and the password, which is the Jane lane that we have been passing in. In fact, when we actually do that authentication here, that's exactly what I was showing you here. That's how this login occurs. You can see there's a post to this URL. And then if we scroll down, we'll see that form data has username and password being passed in. And so that then returns us a cookie that is then dropped inside of our browser. And so we can obviously simulate that with any testing framework. Here we're using Cypress as our testing framework, but we can do it using any other mechanism as before. And so your challenge is to break down this code into these 3 exercises where you can visit dashboard, users, and admin without hitting the UI. And we can do the first one together. So you can see that before every single test, we're clearing the cookies, and then we're performing our request. So let's focus together on this. So we can do it.only as we've learned before. We can save, and now you can see we're only focusing on this single test case. The very first thing to do is to visit dashboard, right, which we're doing here. And then the second thing to do is to get an element that says should contain text welcome, and the instructions for you can put welcome, you can say welcome to the dashboard, right? And so when it succeeds, that's what happens is this message passes. If it doesn't succeed, like let's say we do T, let's do A. Did I put it.only on the wrong one? Can visit dashboard. Let's do, yeah, that was the problem with contain text. Of course, it may contain a single character, so it doesn't contain the number 1. So you can see that it times out, saying timed out, waiting for the header to contain 1, but the text that was found was here. So that's what the error kind of looks like. So now your challenge is to implement the other 2 tests. Give it a shot. When you come back, we'll talk about the solution. All right, so I hope that was relatively easy for you because the other exercises were pretty much the same as the first one. So what we can do here is pull up solution.spec.js, which we've got here. You can see it ran, okay? Let's put it side by side with this window, okay? So these are all through the UI, and these are without the UI. So let's take a look at logging in without the UI. So this is all standard. This you already saw implemented. This was just me having you practice Cypress commands using different URLs, right? So here you're just navigating to users and checking that the text contain users, right? So that's just opening up this URL and going to users, right? And then the other one is going to admin and just making sure that the text has admin. And that's pretty much it. And that's how you bypass authentication using HTML web forms. So the advantages and disadvantages, right? You can see that these tests are fast and reliable, but the disadvantages, you maybe need to learn how your API works. However, maybe that's a good thing, right? As you can see, maybe it's actually an advantage of knowing how the API of our application works so that we can log in without having to use the UI. And then we don't have any of the problems that UI comes along with, which is network, latency, synchronization issues, and slowness, and everything else that I mentioned before. So just to kind of summarize so far, we bypassed one login using session storage in a browser. However, that was only for demonstration purposes to get us started. And now we bypassed another login, and this one is using an HTML web form. So if you have HTML web forms in your web applications that you are testing, you can use the same exact strategy for bypassing UI logins. You simply need to find out which post request and where it's made, and then figure out the body to pass into that post request. And afterwards, you'll get a cookie back that you can inject into your browser. In the next session, we're going to talk about probably one of the most popular methods of authentication, and that's JSON Web Tokens. So let's go, and I'll see you there. All right, so let's talk about JSON Web Tokens. As I mentioned previously, one of the most popular ways of authenticating in modern web applications. So let's go ahead and set up our environment. We're going to kill any processes that were previously running, like Cypress and the server. We're gonna cd into this directory. We're gonna do npm run dev, and then we'll explore our app at this URL. So let's go ahead and do that. I'm going to open up terminal. Here we have Cypress and server, right? Control C to kill it, which kills everything. And then we're gonna cd to logging in and JWT. There we go. And then we're gonna do npm run dev. So we're pulling stuff up here. So we have our project running on 8081. Okay, and the server is listening on port 4000. So there's a web UI and the server, okay? And so then if we open this up, so here's our little Vue.js application, thanks to jasonwantmore.com. And this one uses JSON Web Token. So we can log out of here and we can inspect this. And we can set test and test, right? Let's take a look at our network calls. I'm gonna clear all of these. And then once we log in, so we have a few web requests here. You can see that we're hitting this authenticate API here. And let's bring this up. You can see that just as before was a web form, now it's a post to our server of users/authenticate. We provide a request payload where we're passing in a username and a password. And in return, instead of a cookie, this one actually saves to local storage. It saves us a user that's located here with a bunch of information. And here is the JSON Web Token that was created by our app. This is how our app knows that this user is authenticated successfully and can now access all the secure resources. So that's kind of covered here. You can see you can do post to authenticate. You can do a get here with a bearer token to get all the users that are available. And we kind of explored the application. So how does JWT actually work under the hood if we do some white box analysis of the code? Well, the form fires a handle submit method. The really nice thing, by the way, is if you want to explore all of this, that's why we were using this code base from Cypress code examples, is they actually have everything in here. So if you want to explore it, everything is kind of located for you here. Here's the server, and we can explore the code. But anyways, the form fires a handle submit method that will then read the values of the form, right? The username and the password. Then it fires a web request for authentication. That I already showed you that a web request is fired, but how does it do it under the hood? Well, in this page here, it checks if the username and password are correct, and then it sends a request here to this endpoint. And then it will save the JSON web token to local storage. This doesn't do cookies because it's not a web form. And so again, as I kind of talked about, here is in the user service.js. That's exactly what happens. Local storage setting a user that it gets back from a response that when it hits the endpoint for authentication, it gets back a user, and then it sets that user in local storage. And so with that, whenever a user is navigating through our application, if they have the token, the correct token available, then they can access the stuff behind the actual authentication. I'm not going to cover JWT too much here because we have so much to talk about, but I do have an excellent tutorial on building and testing an authentication API with JWT. So there we covered in depth, we build it and we test it so that you can get a really in-depth understanding of exactly how it works. So with all of that said, now let's write some atomic tests, kind of as we have been doing. So we're going to open up exercise.spec and we're going to create two tests, okay? We're going to create a test to log in with the JSON web token and assert that the user is successfully logged in. And then we're also going to assert that a user can successfully log out. And for this one, you're not allowed to log in through the UI. Okay, the JWT authentication, I already implemented that for you because it can be a little bit complicated, especially if you're not familiar with the Cypress API. So let's take a look at all of that here. So if we close this up, both of these, oh, that was web forms. Here's JWT, by the way. I was showing you totally the wrong source code. Here's the source code that you would look at. If you want to look at our app, there's the server, there's the code, but our tests are in Cypress integration just like before, right? And then if we open up exercise, we can see several things here. So we can see a before method. This will actually run a single time before all of the methods. So it's not a before each, it's a before once basically for the suite. And here you can see we do a web request to get an authenticated user back. It's a post to this endpoint. Simply supply the username and password as I've shown before, and then we get back a response, and we're storing that response in our authenticated user variable that we created here. Okay, now let's actually put this side by side with Cypress so we can put this here. One unfortunate thing about Mac is they need to introduce keyboard shortcuts for tiling. In Windows, for example, the only thing I miss about Windows is that it used to do tiling really easy with like keyboard right and left, command right and left keys on the keyboard. But with Mac, it's drastically harder. Don't need this. Sorry about that. I am not the best at multitasking, talking and doing it at the same time. And we're pulling up Cypress here. Let me make sure this is the right one. Yeah, this is the right one. Shows logged in user and should log out. Yeah, this is the right one. Let me make sure here. Bypassing UI login. Yep, perfect. And then yep, shows logged in. Yes, perfect. Okay, so let's continue here along. So these are our tests. So before each one, right, we visit our application URL. That's what you see here. Of course, being stored in Cypress JSON. We don't even need this part. It should work. Yeah, just fine. And then we are setting our user in our application as such using window.local storage from Cypress. And then we're just turning into a JSON object our authenticated user. Okay? And so now that's been implemented for you. You can already see that when we visit, we're already automatically logged in, right? So your challenge would be to write a test that shows a logged in user that we've authenticated with JWT. And then the other one is to be able to log out. Now, by this point, you should kind of know how to use Cypress. So I'm not going to do the first one with you you can do it yourself. But of course, there are instructions here all throughout, step by step, on how to accomplish these goals. So give it a shot. When you come back, we will talk about how to make this happen. Okay, so hopefully that wasn't too hard for you and you were actually able to make it happen, especially because we had most of the stuff implemented. So here is how I did it. You can see, by the way, I got tired of constantly pinning and repinning different windows between exercise and solution. So I did a little cheat, right? You can see this is just a URL. So I just navigated, you can navigate between exercise and solution here. Right, just like that. And so let's take a look at our actual code and what we were able to do. So shows logged in user. We simply use cy.contains, which you were given instructions on. And then we are checking that this list item contains test user. So what exactly are we talking about? So if we come here and we use the selector playground, we can come here, click on this. You can see it's a li element, right? You can do cy.get, or you can do cy.contains, and you can do, for example, test user here, test user. And so that, look, it even highlights for you. And so now we could copy that to the clipboard, come here and paste that, for example, if we wanted to do that. And then we just do a should, which you're familiar with, and be visible, one of our favorite assertions. So that one is relatively easy. So here is, you can see there's a web request to this endpoint, and then we're getting back his body and performing the rest of the operations. The should log out, that one was a little bit more challenging probably for you, because you had to do may have one extra operation as opposed to only one. So for that one, right, the important part was to get this login link. It's funny that, oh yeah, it goes to login. So you of course can use it, could have used the selector playground by doing this, which is this one is a horrible selector, obviously, right? So instead we can do it ourselves by coming here, inspecting this logout link. So here you can see, right, I've referenced it by href login. You can even reference it by the name of the link. And then we just do a simple click. And by the way, don't forget, if you're writing this, you can do only, which will allow us to focus only what we're talking about, right? You can see should log out. And then we click it, and then we just assert that the login is present, should be visible. Super simple. Let me remove the only. And then one other thing that I did want to show you all here, that wasn't part of the exercise, but I just wanted to show you how it could be possible, was that you can even make authenticated requests, right? So if you wanted to get information from some endpoint without actually hitting the UI, what you can do is perform these web requests. So you can see this one, for example, hits users. That is, so I believe it should work right now. So if we do this, it should come back with data for us. Oh no, invalid token. Yeah, that's because the token is only valid in that tab. The bear token is only valid in the tab, which I've showed you all before. That comes from here, from this user. That's the token that's being passed in. And when we make the web request, we set a bearer token. So that's, you use authentication, and then you put in bearer, and then this is the key, and then this is the value. And so then this will allow you to access a bunch of different stuff behind the scenes using web requests. And actually I cover this in the tutorial that I showed you, but if you did want to do that in your own application, that's exactly how you would do it, is by setting that bearer token, and then you can see that it comes back with a bunch of this data that is available behind that endpoint. And so when we do that endpoint, you see we get back this object with a bunch of this information, and it works. Cool. So to summarize, pretty much all authentication can be bypassed without using a UI. At this point, we should be testing a UI once to make sure that a user can log in successfully. And then after that, we should always be bypassing it and then performing the rest of our operations using standard UI technologies. In this workshop, we learned 3 types of authentication: HTML web forms, JWT, and directly setting session storage, which I already mentioned. That's not a realistic scenario. It only works in our demo app, even though actually the newer version of our demo app has been updated to be more realistic, and it sets local storage instead of session storage. So in a future session, I'll come up with some code examples and show you all that. So, but keep in mind, there are many other ways to authenticate. SSO is probably another one that you all are very familiar with and is very common. And so you can learn a lot more by looking at the different logging in examples in the examples folder of the forked repository that I have here. You can see here all the other login examples. You can take a look at those and see how it works. But for the majority of us, JWT and SSO likely covers most of the use cases out there for testing purposes. All right, so with that said, we still have so much fun stuff to cover. We just finished login testing. Now we're gonna get into what I think is my favorite portion, is the full coverage testing, where we're gonna take a web app and we're gonna make sure to write tests to provide it full test coverage. And then we're gonna put it all into a CI pipeline that executes everything step by step. So we still got a lot of fun stuff to do. Let's go and get on it. Okay, welcome to the full coverage testing section. I think this is gonna be your favorite section, as it is mine. Here we're gonna learn how to write component tests, how to add a test ID to our web app, how to correctly test links and tabs, and how to replace end-to-end tests with component tests, because we all know that component tests are drastically more efficient. So we're basically back to the repository that we were working at in the beginning, because we're done with logging testing. And so everything will only be taught from my React app directory. So what does that mean? It means that we'll go back here to Visual Studio Code. We can close the Cypress window. We'll open up our terminal and we will stop this server. So kill everything that was running before our web app. And in fact, what we can do is actually close this repository and open a new one. So we're gonna open up automation best practices again. And then at this point, we're going to navigate to my React app, install if you haven't installed before, and start up our app, which you should have done from the setup section. Let me just kill this window here. Cool, so let's come here and do that. So cd my React app and then do npm start. Okay, so by the way, if you get this warning, you may have something running on port 3000. On my machine, it's typically Docker, so I'm actually going to quit Docker because we want to use port 3000. If not, you can say hit enter here and then it'll run on the next port, 3001, for example. So I can kill this and then rerun it, and now that should work. But otherwise it would be on port 3001. So keep in mind, because that could mess with the exercises. If you run on a different port, you just have to make sure you update the base URL accordingly. Okay, now I have it on port 3000. So this is a very simple web app. It has only this page here. It was create React app. And you can see it has an image, it has some text, and it has a link that you can click, which will open to ultimateqa.com, where you can learn testing with me and Mia, which is my dog, which you will meet later because she will be the star of the show. So the point of the app being so simple is that we are going to focus on a good testing strategy for this app. Here is how that testing strategy is laid out. And what I hope to show you here is not only how to do all this testing efficiently, but also how much testing there can be to do on such a simple app. And now imagine that scaled out, of course, to a much more complicated application. And then that kind of shows how hard testing can be. So here is our testing strategy and our expected behavior and whether it was tested or not. Here we're going to put the type of test that we do in order to achieve this expected behavior. And then in here, we're going to put the technologies that we're going to use. And as we do the different types of testing, we will fill out this little form here. Okay? So to start off, what is the most basic test that we can write for our application? Well, how about making sure that our application actually renders? And so now that is your challenge, is to open up Cypress and make sure that our app actually renders. So you can follow the instructions here. And when you come back, I'll give you the answer. So we go back to Visual Studio Code, right? We can open up a new terminal here. And then we're already in the correct directory, my React app. So we'll do npx cypress open, which will open up Cypress exactly how you've seen it before. You'll see the same thing you've seen before, solution and exercise. We'll open up exercise, and then we'll pin it to the right side. Excellent. So then we'll actually come back to, in my React app, Cypress integration exercise.spec. We'll close all of this, and now it will actually perform the operations here. We're even focusing on this one test already, which is fantastic. So we're going to do site.visit, right, which will navigate to the correct app URL. We already know that the base app URL is stored in cypress.json. And now we're going to get the app link that should be visible. So how do we know that that's the app link? Well, we can come here. We can, this shows test ID learn link, but we can use our inspector. Look at this element. You can see here it has this class, right? We're simply using a CSS selector here. Dot means class, and we're looking for the app link and that it should be visible. And so then that test passes successfully. And then how about should click a link? We can do that one as well. So let's remove this. And we'll just leave both of them to run, no problem. So we can use site.visit as before. Then we can use site.get to get our element, right? So here we're gonna do that. But of course, instead of validating that our link is visible, we're going to click it. So there's a click method. And then finally, we need to make sure that our URL is not here anymore, right? Yeah, so this will click it. It'll open up a new tab, and then we'll make sure that it did not open in this tab, that it opened in another tab. And so we can do, for example, site.url, and then we can do should. And then, of course, we can do not contain. And then here we'll say qa.com. Cool, let's give this a run. So you can see it did open. And our test has passed successfully because this didn't change and this was opened in a different tab. So a quick question for you to ponder. Does this test guarantee that our app works as expected, the tests that we just wrote? Pause the video, think about it. When you come back, we'll talk about it. So here is what this test actually did test, right? It tested that our app has a corresponding class visible. It doesn't mean anything for the functionality of the application. It just means that, yes, there is a class called app link and our app renders in the UI, which at least is a good thing, but it doesn't even mean that the app is looking as expected or working as expected. Because, right, we can have a totally wrong application in here, and all it has to do is have an element that says app link. All we have to do is have this exact HTML element in here, and our test will pass successfully regardless of what's going on with the rest of our application. So if we actually stop our app, let's come back here, open up this, and our app is running here, right? So we're going to come back here and stop it with Control C. So now if we rerun our tests, oh, these aren't doing anything. Yeah, of course. Let me do the solution. If we rerun our tests, you can see that our tests fail, right? It said it was failed trying to load localhost 3000. So ultimately, these tests are checking that rendering is working as expected and that the server is running. That's one of the nice things about an end-to-end test. It checks everything from the top, the UI, all the way to the bottom, and that it's connected. Now, the disadvantage of this test is that it needs all of these extra things. It needs a browser, server, network issues. The test is going to be slower. And not only that, we need to learn extra dependencies such as Cypress and the API that goes along with it to be able to write an end-to-end test. So can we do the same thing more efficiently? Of course we can. That's exactly why we're here. So that's where component tests actually come in. And reactjs.org defines two ways how we can test an application. We can render the components, meaning the HTML components, in a simplified test environment and assert on their output. Or we can run a complete app in a realistic browser environment and do end-to-end tests. That's exactly what you saw with Cypress. With a component test, we are actually testing only a tiny piece of the application, whatever we are interested in. So here you can see a wonderful diagram from Yoni Goldberg. And a component test is this green part, right? A component test may have an API, it may have a domain layer, and all of those get packaged together, and we can test these three pieces together. Unit tests, they function at a very low level, meaning that if you have a microservice, you can just test a microservice. If you have like little components here in the domain, you can test those themselves. So that's how unit tests work. And end-to-end tests, as I've already alluded to, they basically capture the entire stack, right? This is our whole application rendered and packaged, and we're testing from the top all the way to the bottom, just like that. Some people intelligently refer to end-to-end tests as DOM to database tests because they test from the DOM all the way to the database. So the advantages of component tests are numerous. You don't need any of the previous things that I've mentioned that an end-to-end test does, end-to-end or a DOM to database test. DOM to database, to be honest, that's a better term for it. A lot of people refer to end-to-end tests as screen-to-screen flow tests. I'm only talking about end-to-end tests as DOM to database tests. It has all of these benefits, which is fantastic. But not only that, as I previously have mentioned, our app was created using Create React App. And so because we did that, we automatically got testing library, we got Jest, and we automatically got a component test that looks exactly like this. So here's this very simple component test that came with our app that says that our application renders the learn React link, right? So we're rendering the component in question, then we're getting an element, and then we're expecting the element to be in the document. So it's exactly what we were doing before with Cypress, except in this case, there's many other advantages. Just a little background for everyone. Testing library is an opinionated framework that helps with component rendering and interactions, and Jest is a test runner that provides a bunch of capabilities like matchers and snapshot testing. So let's actually try to run a component test. So we are going to stop Cypress, okay? And we are already here in our application, and let's run some tests. So all we have to do is do npm run test, and that will run our component tests. Okay, so the component tests, they live not in the Cypress folder, but they live here in the source __ tests folder. This is the standard convention followed by Jest. And so that's where our component tests were placed. In fact, you can see here's our exercise and here's a solution for component tests. The exercise looks exactly as I showed you before. Oh, sorry about that. With this test, okay? And so if we want to run all of our tests, you can see here we started up a new window. We can click the A key, that'll run all of our tests. Okay, it's going to run exercise and solution. You can see we ran 2 test suites and 5 tests passed. Okay, but of course we're currently working on exercises. And so if we want to filter, we can click the P key and start typing exercise.test.js. And so you can hit enter key, and now it'll only run everything in the exercise file. And so you can see that the tests have passed successfully. If we change something about this test, you'll see that the test actually fails. So here the test failed, and it's telling us very nicely that renders learn React link failed. It was unable to find this element with test ID learn links. Of course, it doesn't exist. And then it prints us the HTML that does exist. Okay. And then it gives us some more kind of help here in terms of what is going on. Now, one other thing to note for you to note here. Notice how my app is not running. The server here is not even running. And so if we come back here to our app, refresh it, it's not available. So that's one of the very cool things about component tests, is we're still making sure that our application is working successfully without actually needing to run any server code. So with that said and shown, my question for you is, what does the Cypress test validate that the component test does not? This is important because if we replace one for the other, we need to know what coverage gap we've introduced. So the Cypress test, as I've mentioned before, it actually does test that the server is running, right? You can see that even though our application is not running, the component tests pass. And so our app may be completely down in our production environment, but our component tests may be passing because the application code and the test code are working as expected. So keep that in mind. Just as a side note, we always talk about adding test IDs to applications, especially in web automation, because test IDs are really nice to have. And it seems to be a big challenge. I always get pushback where people say, the developers don't have time to do this for me, or people don't seem to want to talk to the developers. So I wanted to show how simple it is to add a test ID to an HTML element so that we can either do it ourselves by pulling up the code, creating a pull request and adding an ID ourselves, or asking a developer to say, hey, can you please add this to our application? So let me show you here. I'm going to do one thing here. I'm going to change this. Take this. And update this. And it's not going to be learn React. It was here. Let's run it so you see exactly what happens. By the way, here's again the nice part. Save it is going to rerun automatically, fail. And then we can come here and get the text. Here's the text, right? Save it again. Now it should pass successfully. Wonderful. And let's take this and apply it to this as well. This should pass as well. Save that. Okay, successful. So now, your exercise, you can add a data-test ID attribute to our element. Actually, data- attributes are the best to add to our HTML code, and then IDs are second best. So keep that in mind. That's why we're adding a data-test ID attribute to our element. You can simply also just add an ID as well. And so we can navigate to our application and follow these steps. When you're done, make sure you save your test and update the test code accordingly. And then when you save the test, they'll rerun automatically, okay? And then give it a shot, pause the video. We'll tackle the solution in a moment. So let's do this together. Come back to here, app.js, and you can see this right here is our link in question. Here's where you would add the data test ID attribute, right? If you wanted to add an ID, you can as well. You can add whatever you want here. And we added this string that's called learn link, right? And so if we run our test currently, they were getting our link element by text. However, we can change this to get it by test ID. Get by test ID. And so now we can supply the test ID, which was learn-link, right? And then you can save it, and the test should still pass successfully. This, by the way, is coming from React testing library. And so when we add that test ID here, it allows us to use this method here. And one other thing I should talk about, I quickly breezed over this. This part is where we're actually rendering our component. We're rendering this component here because that's what we want to test. If we want to test something else, like let's say you have a header or a footer, you can render that and just test that individually. Again, one of the powers of component testing, being able to focus on what you're really testing. And then we're simply expecting that link to be in the document, right? So if our app didn't have this, just to show you what happens if it fails, so we'll save this, our test will rerun. You can see that it fails, right? Renders learn React link failed. Why did this one pass? Well, because it's using the old locator that we were previously using. You can see it's getting by text. So if we change it to this one, then that one will fail as well. So that is how easy it is to add any attribute to an HTML element and then be able to use it for test automation. So how are we doing? Is our application actually fully tested? Well, no, not even close. As you can see, we still have a very long way to go. We've learned a lot. We learned about component tests. We learned how to add a data attribute to an HTML element. But so far, the only thing that we know is our application renders. And we tested that with a component test using React testing library and Jest. Now, let's continue, right? We still have functionality to test. So the fact that learn React links goes to the correct location. So testing links the right way. Here's an end-to-end test to validate that a link works. You've already seen this test. We clicked on a link and then asserted that a specific link will contain a specific URL, right? Or you can assert on an element. Why is this test actually bad? Think about it for a moment. This test is not good because number one, Cypress doesn't have multi-tab support. There's a reason why they do that. They do that because we should never need to test that a link is clickable. In fact, the clickability of a link is a browser's native behavior. So if we're testing whether a link can be clickable, we're technically testing third-party services. Furthermore, we should not even need to test that a link opens in a new tab. This is something that I commonly see in test automation. And so although this test specifically doesn't validate that we open in a new tab just something else to mention and keep in mind. And so how do we get around this? How do we actually validate that a link behaves accordingly without needing to click on it with the end-to-end tool? So what we can do is do the same thing with the component test, right? We saw a component test can validate the rendering of an application. Why don't we validate some functionality as well? And so here is the test that we can do. We can create a test called link has correct URL. So navigate to this file and perform the exercise that you see down here. And of course, when you save, the test is going to run automatically. Go ahead, take a moment to do that, give it a run, and then when you come back, we'll continue together. So welcome back. Let's continue in our test, right? So we have our exercise here, and the exercise is to check that a link has a correct URL, right? So before we were getting by text, which is not the best option. So let's replace this here and so we can do screen.get by test ID. Wonderful. And then that test ID was learn link. Okay, let's save that. It should run and pass. And then obviously the way that we can check that an element has a correct URL is simply by checking the href attribute. The href attribute is this right here. This is what we're actually interested in testing. We don't care whether when we click on the link, what we actually care is that it goes to the right page. So why not just get the href attribute and assert that the link on that href attribute is correct? And so that's how we do that with a component test without needing an end-to-end test. So what if we wanted to actually test and validate that this opens in a new tab? So one expectation here is whenever we open our app, let's open it up again, localhost 3000. Oh, the server is not running. Let's open that up and do npm start. So here's our app. Give it a moment to load. So when we click this, you can see it navigates to this URL, right? And it also opens in a new tab. So how do we avoid actually testing this with an end-to-end test and doing all the clicking and stuff like that? Well, so if we look at the source code, that's this target underscore blank attribute. If that's there, then we know that our app is going to open in a brand new tab. That's again, native browser behavior. In fact, I can show you that I'm not making this up by coming here, opening, and check out this link, right? What'll happen if I delete this? There we go, right? And now I click on this link. Watch what's gonna happen. See, it opened in the same exact tab. So that's what happens if you don't have it. So instead of actually clicking and checking whether it opens in a new tab, what Cypress recommends and good testing practices recommend is to simply check for the, simply check for the target attribute and expect it to be blank. So here, let's exit out of this. We can do P, and now we can start typing solutions.test.js. Let that run. 3 passed, and this third one here, that's an extra one. You can see that we're checking the target attribute to be blank. Okay, fantastic. So now, how are we doing in our app testing process? Well, take a look here. We've now tested that a learn React link goes to correct location, right? We did that with another component test. Same technology, and then we check that our link opens in a new tab with a component test. Cool. But with all of that, does that even guarantee that our application is going to look good? No. So far, all we've been doing is testing this link. We don't know whether this image is correct. We don't know even if this app looks like it should. And in fact, what happens when we pull it up on mobile or other browsers? How is that going to look? And so that's exactly what we're going to cover in the next portion of our journey. That's going to be with visual end-to-end testing. And the other thing I want to say is that we're not actually going to be doing front-end performance testing and making sure that our application is secure, but I put that there simply for you to understand that there are far more tests that we can do besides our functional testing journey here. So just to summarize, so an end-to-end Cypress test tests the connection from the front end to the back end. Right? That's what it's good for, making sure that everything is working together. But most functionality of a modern web application can be tested with component tests in a virtual DOM. We did this by testing links, tabs, and making sure that HTML is how it should be. So with that said, let's go and do visual testing where we're actually going to render our applications and make sure that they look correct, whether on mobile or on desktop or in different browsers. So welcome to the visual end-to-end testing portion of this workshop. In here, we're going to learn what is visual end-to-end testing, and we're going to learn how to implement the visual end-to-end testing with WebDriverIO and Screener, also known as Sauce Visual End-to-End. Before we get started, I want to cover a little bit about what exactly is visual testing. So visual testing is basically making sure that your application looks how you want it to look on whether a mobile device or a desktop. There are some really cool statistics about how the digital experience is extremely important and how different kinds of businesses earn more revenue whenever they have a better user experience. So visual errors can occur in many different places. I got some real cool world stories, one of which was an avoided nuclear disaster where a display was showing that rockets from US were being sent at the Soviet Union. And luckily, this guy Petrov decided not to trust those visual cues on the machine, avoiding a nuclear disaster and not sending a retaliatory strike. But that is one example of the different types of visual errors that can occur. Now, more modern types of errors and less scary are websites such as Southwest, where you can see here this continue button was covered up by this text, making purchase impossible. I think I saw somewhere that Southwest earns like $3 million per hour from their website. And so you can imagine that even if this was up for a short period of time, this bug, how many millions of dollars it cost the company. Here's an example from my very own website. I created it on a nice 1080p resolution monitor, but then however, I noticed that whenever I would bring it to smaller resolutions, this kind of stuff would happen, right? My text would start blending together, my search icon would go in a different place. Now, this is not a multi-million-dollar mistake, but it is kind of embarrassing for me as a quality assurance engineer and anyone else coming to the website and having such a poor user experience. So how do we prevent such bugs? Well, with visual end-to-end testing, of course, and as I kind of already talked about, it's basically ensuring that our app appears to the user as we intend it to appear. So with all that said, let's go ahead and actually dive into the rest of the workshop. So we are going to use WebDriverIO for doing visual testing in this portion of the course. WebDriverIO is a next-gen browser and mobile automation test framework for Node.js. So it's really nice because it works very well with many other tools. It's similar to Cypress in that it can do browser end-to-end functional testing. It's different in that it can also do mobile testing and really easily integrates with cloud grid providers, provides Cucumber support, and so on. It's very easily extensible. And then Screener is the visual end-to-end testing tool that is part of Sauce Lab. So we call it visual end-to-end these days. There's also visual component testing that allows us to test only components in different kinds of states, but we're not going to get into that here. Maybe in a different, more advanced workshop. So let's go and set up a visual test. So you're going to follow the instructions here to set up. You're going to set up this code. You're going to want to make sure that you have your environment variables set up for Sauce Labs and for Screener. And I'll show you those username and access keys to access. And then this will be our test. So let's come here. We'll still be in my React app. However, the standard convention for WebDriverIO testing to go into test specs area. So we're going to come here and take a look at this test. You can see here is our test. Next, WebDriverIO gets a WebDriverIO config. And so here are the environment variables that you need set. You'll need a username and an access key. And you'll also need a Screener API key set. And then your application will work. So what I'm actually going to do now is come here and do npm. Oh, sorry, we need to quit this. We're going to quit, and then we're going to do npm run test visual. And so now this is going to execute our tests, visual tests. So if we look in the Screener dashboard, we can see that we currently have some tests running, and we can see the status of which kind of tests are running. You can see that we are running visual checks on this resolution and this smaller resolution, which represents an iPhone X resolution running on Safari, and this one runs on Chrome. And the very first thing to notice here is that our test has failed, and the reason it failed is because there was 2 changes that happened to our application. Let's go and review those changes. So what happens is whenever you run a visual test for the first time, you have to manually set a baseline. There's no way for any algorithm to know whether your application looks correct or not, right? One application may look correct, another one may look incorrect, and the only way to know whether it's correct is by setting a baseline. You can do that manually, or you can auto set the baseline through code, but the better thing to do is to do it manually so that you can actually validate that when things are rendering, they look correct. And so I've already previously done that with this application, and I'll show you how to do that process. But in the meantime, let's take a look to see why our tests have failed. So what you can see here is we had a previously accepted version of this application where we had these cute little dogs fighting. By the way, that's my cute little dog Mia battling another dog in the park. And you can see that what's changed is this image in the center. Screener highlights it, and we can see the differences here side by side. We can open up here and we can see the different types of changes that occurred. So we had a layout change and we had a content change. The layout change says that the width has changed and the image has changed. And here we see that the source has changed as well of the image. If we decide that this change is not important and we never want to care about it, maybe you have a date picker, maybe you have a header at the top that has different kinds of news or different kinds of alerts, you can ignore it. You can ignore it manually, or you can ignore it through code. And then from that point forward, that element will never be checked again against the baseline to see if it's changed or not. In our case, we like this version of the application. So what we're going to do is we're going to say accept. And so now this version of the baseline will be used from this point forward. Let's take a look here and see what happens. So this is on a larger resolution on Chrome 90 and Windows 10. Same exact problem. So here we can come here and say accept. Now, of course, if you have many different kinds of changes, you can come here and click the accept all selected button and accept them all at the same time. You can see different kinds of states whenever those different kinds of states are here, right? Like that. So let me show you how we ran these tests on cross-platform. But also I need to talk about the tests because we didn't even cover what they do. So let's go back to our test, which is not here. Let's pull that up here. I'll close out all the other tabs. So just to make sure you understand what's going on, here we're navigating to a URL. This is now WebDriverIO syntax. The browser is a global component that doesn't need to be imported. So you can see we do browser.url. And then we execute this command that sets the name of the application. So in our case, my React app, that was set right here. You see that? It says my React app, okay? And then, so you have to do this once in your test, and then afterwards, you capture as many snapshots as you want. So you can navigate page to page, you can click URLs, you can log in, as we've been learning about, and you can capture snapshots of many pages in a row, and then they'll all appear in that view. And then the way we ran this cross-platform was by configuring some capabilities here. You can see these capabilities that we set, and we are saying that we want to run on this platform and this platform. And you can even see how we control the viewport size, for example. And so that's the beauty of a visual test, is that we can do so many checks at the same time and run it cross-platform so easily. And we've written one test, we made some configuration updates, and now we can continue to add more visual checks here and navigate through different portions of the application and checking all of them for a good state. So let's actually change our image and see what breaks. So here is your challenge that you need to follow. Give it a shot, and then when you come back, we'll talk about the solution. But basically, we're changing the image of our application, saving it, and then rerunning visual tests. Okay? So give that a shot. When you come back, we'll talk about that. All right, so hopefully you were able to do that successfully. If not, let's take a look at the solution. So we are going to be modifying our app, right? So you'll come to app.js. So what you can see here is currently the logo that we are using in our image source is coming from this logo SVG file, which is right there, right? If we click it, it doesn't really show up, but that's where it's coming from. So if we want to change that, we can just point it to a different file. So I've already included a picture of my super sweet dog. So we just have to do mia.jpg. I don't know why. And so that should restart our app. And so now you can see my sweet little dog in this application, and it looks much better. So what is going to happen when I rerun the tests? And the other thing I want to show you is, yeah, let's rerun the test and see what happens. Okay, so let's take a look at our UI. You can see we have a failure in our app, right? Let's review what's changed. You can see here, it's exactly as we expected. Our image has changed. So now at this point, you decide whether you want to accept this or not. As I've shown you before, we can accept all selected, which means that we're happy with our changes. This is the new way that we want our application. And now our dashboard shows that everything has been accepted successfully. Cool. And so now we've tested pretty much everything that we can about our app except front-end performance and the security of our application. We could probably even take it another level and do accessibility testing, but at least in terms of functionality and looks, we know it looks and works correctly. And we did that with visual end-to-end testing in this portion, which is a quick and efficient way to test your web app cross-platform. And we used WebDriverIO screener to write our visual end-to-end tests. And in the final piece, what we're actually going to do is put everything together into a single CI pipeline that's going to run all of our tests one by one and make sure that our application is actually ready to be released on every commit. So let's go and do that. Okay, so in this final section of the workshop, we are going to talk about CI/CD pipelines. CI/CD pipelines are a critical component of automated software testing. In fact, these days, it's really important to get not only really fast feedback, but also continuous feedback. And that continuous feedback allows us to get back signal from our application about what's going on. The more often that we can get feedback from our application, the higher quality our applications will be. This has been regularly proven by data in the industry. And so we're going to set up a CI pipeline that will run all of our tests on every single commit. So let me show you exactly what that's going to look like. So we'll come here to Actions, and you can see actually I recently just made a push into the main branch, and our pipeline ran in 1 minute 22 seconds. It failed. Let's take a look at why it failed. We can come here and click on that, click on the build. Here is the failure. The failure happened on running component tests. We can scroll up to see exactly what happened. So let's see. What happened was testing library unable to find element data test ID learn link. So our exercise.test was trying to find data test ID learn link, and it wasn't able to find it. Why wasn't it able to find it? Was because you can see in our HTML there is no such attribute, and this other test also failed for the same exact reason. Okay, so that's one example of the types of logging that automatically come from our CI pipeline. You can see there are a bunch more steps, such as setting up the job, downloading Node 14. You can see we can install dependencies. We build the application so that it's deployed on a server in our CI pipeline. Then we run component tests. And then if those had passed, we would have started the app. We would have ran functional tests, visual tests, and so on and so forth. If we want to see a fully complete pipeline, let's go back here, take a look at a previously working pipeline. We can take a look at this one that succeeded in under 3 minutes. We were able to build and test our entire application with everything you've seen. So we built the app here. Then we ran component tests, which succeeded. All 5 of them succeeded. Afterwards, we are starting the app. Starting the app here. So let's scroll down. This is actually doing the npm start, how you've seen. And then after our app is started, at that point, that's where we can do functional tests, right? Functional UI tests and visual tests. You can't do that without a running application. And so that's where we're running our functional UI tests. So here you can see we're running Cypress. We had 1 test that passed from exercise spec, 2 tests that passed from solution spec. It shows all of those results here. Ran in 3 seconds, which is pretty fantastic. And then overall, here's exactly what happened. Everything passed successfully in 7 seconds. And then finally, we can see the visual tests, which also executed. These are from WebDriverIO, all the logs from WebDriverIO showing exactly what happened. If we scroll here at the bottom, we can see we had our 2 tests passing, right? We had a test run on Safari and Mac, and a test running on Chrome and Windows, and both of those tests passed successfully. So that is our working CI pipeline that we're going to have at the end of this that will run on push and pull requests. So how do we actually make this happen? Well, let's go back to our IDE. And what the technology that we're going to be using for this are Github Actions. They are fantastic. It's been the best CI system that I've used, at least in my career. It's very user-friendly, and the best part is it's absolutely free. And it's also nice that it automatically integrates with GitHub, which is the most popular source code repository, right? So to set it up, what you're going to need to do is create a .github/workflows folder, and then you put a YAML file in there. So you can name it whatever you want. Mine is called nodejs.yaml. We can rename it to ci.yaml. That's fine. And then you can structure it like this, okay? At the top, we set a name. This is saying the name of the CI pipeline. We can actually even change this, and let's say CI for React app, okay? Then at the top, we're setting these environment variables, right? This is how we are able to talk with Screener, and in the future, our Sauce Labs cloud for cross-browser and cross-mobile testing. Let me show you how actually this works, okay? These environment variables. It's really easy to set that up in GitHub Actions. So you come to settings, you'll go down to secrets, you'll see these repository secrets, and then you just have to click new repository secret. It'll allow you to add a name of the variable and the value. So if we go back, you can see that I have 3 of these already created. Here's the name, and inside of this, there is a value. So when we're actually looking at Visual Studio, what we're saying here is we have an environment variable in our code that we're using called Screener API key. The value of this environment variable is going to come from secrets, which is a variable of GitHub Actions, dot, and then the name of the key that you provided in GitHub Actions. So I made these correspond accordingly so that I know, but that's how GitHub Actions, it retrieves the value from here and stores it in an environment variable in here. Next, we have here the on command, which says when do you want to run the CI pipeline. So we're saying on push and on pull requests whenever they happen to the master branch. Next, we have the jobs part, where this is where all our jobs will execute. We're saying run on Ubuntu latest. We're going to run with Node version 14. And then we have all of the steps. So first, we're going to check out the code. Next, we are going to use Node 14. Next, we're going to install the dependency. So now here is really where the stuff that we do comes into play. So it's basically everything that we've been doing so far. Now we're just putting it into a YAML file with bash scripts, right? So you can see I provided this script here that says we're simply CDing to my React app. And then typically on local machine, we're doing npm install. Inside of a CI system, like GitHub Actions, npm CI is actually faster because it ends up caching dependencies. So we use npm CI instead of npm install. You can use npm install, but it'll be slower. Then we're building the app. This is something that we didn't do locally, but in order to run our application in production mode, you need to do an npm run build, and then it becomes production mode. So I'll even show you an example. If we cd to my React app and then do npm start. So what you'll see here is here I have the little React dev tools here, and you can see it's red, and it's saying that this page is using the development build of React, and that's because instead of doing React build, we're npm build, we're doing npm start, and it's not a production build. And so we want to have a production build by doing npm run build. Next, we're running component tests, right? We don't need our application actually running at this point in order to run component tests. So just doing the standard npm run test. Then we're starting the application. Now at this point, the app and the server are actually up and running. And so we're starting it with this command. And then it's important to wait on our application to actually come up we're doing for a maximum time of 60 seconds. And once our app is up, we're simply running functional UI tests. And then we're running visual tests. And that's pretty much it. And with all of that, that's how our CI pipeline executes. Let's actually commit the little change that I created. And then we'll just say name change to YAML. We'll push that up. And so with that, that's going to start running our CI pipeline. We'll come back here, come back to actions. You'll see that now we have a name change to the YAML that we committed here. You can see that this is the part that we changed, right? CI for React app. It's changed here as well, but before, this used to have a different name, which was the name that we had in the YAML file. And so that's how those correspond. And then of course, now this one is just going to execute all of the steps that you've seen before. The other thing that I quickly want to cover here is that I actually didn't fully create that entire YAML myself. I had some help from GitHub Actions. So if you want to do this yourself from scratch, the easiest way to do it is to come and say new workflow. GitHub Actions is smart enough to provide you a template. So here it knows we're using Node.js. So it's saying set up this workflow. So this is how I was able to get the majority of the stuff that I need. And then afterwards, really, I just modified this. And instead of running on this entire matrix of all the Node versions, I simply change it to 14. Of course, it can run on these multiple Node versions if you want. And then again, just updating the steps here accordingly afterwards. And so that's pretty much how we're able to run an entire CI pipeline. So thank you so much for joining the Automation Best Practices Workshop. It's been a pleasure serving you. My name is Nikolai again. And before you leave, I have 2 call to actions for you. First, be sure to follow me on Twitter or ultimateqa.com, where I regularly provide this kind of information to help the community grow in their testing and development practices. And second, we should always be giving back to the whole world. And so if you can, help us to save the planet. The planet is in trouble, and I've provided 3 simple ways that you can take action every single day in order to help the planet just a little bit. And if we do it together, we can make an amazing impact. Thanks again so much. It's been a pleasure serving you and working with you today. Don't be afraid to reach out to me on social media and ultimateqa.com, and definitely see you next time. So if you're enjoying this information and want to learn a lot more, we have a bunch of different self-paced testing courses that'll help you to up-level your testing skills. And this month we are running a massive special where we're giving 25% off to anyone that uses coupon code YouTube25 at checkout. Simply go to courses.ultimateqa.com and use the coupon code for whatever course fits your needs there, and you'll get a massive 25% discount. All right, back to the presentation.